Hello students, Jai Swaminarayan. We have learnt that the earth attracts all objects towards it with a force which is called the force of gravity. It is because of the gravitational pull of the earth that every object gets attracted towards it. Now let us see the meaning of free fall. When a body falls under the effect of the gravitational force of the earth alone, it means that there is no other opposing force acting on that object. It is coming down only because of the gravitational force of the earth. Then the body is said to be in a condition of free fall, and the body is known as freely falling body. When a ball is dropped from some height, it falls down under the effect of gravity alone. Earlier, it was believed that the heavier body falls rapidly than the lighter body, because when a feather and a stone are dropped at the same time from the same height, the stone reaches earlier than the feather. The feather takes more time to reach the ground than the stone. It was proved wrong by Galileo. He dropped two stones of different masses at the same time from the top of the Leaning Tower of Pisa and found that both the stones reached the ground at the same time. Galileo explained that in case of stone and feather, the stone reaches earlier than the feather because feather has larger surface area as compared to that of the stone. Hence, the feather experiences greater frictional force due to air than the stone, and hence takes more time to reach the ground. If there had been no air, the stone and the feather would have reached the ground at the same time. This was proved right in an experiment conducted by Robert Boyle. He dropped a coin and a feather in a jar whose air was removed by using a vacuum pump. He found that both coin and feather reached the bottom of the jar at the same time. It means that in vacuum, all the bodies take same time to reach the ground when dropped from the same height simultaneously. Now let us discuss about acceleration due to gravity. When we will throw the ball upward, what will happen? It will reach to a certain height, will stop there, and again it will come down. Have you ever thought why this happens? When a ball is thrown vertically upwards, the force of gravity acts downwards. Hence, the velocity of the ball decreases. When the ball reaches the highest point, it momentarily comes to rest and the velocity of the ball becomes zero. The ball then starts falling downwards under the effect of gravity and the velocity of the ball increases. Now from that example, it is clear that when the body moves against gravity or towards gravity, its velocity changes. We know that when there is a change in velocity, an acceleration is produced. In the above case, the acceleration in the body is produced due to the force of gravity, and hence the acceleration so produced is known as acceleration due to gravity. Thus, we may define acceleration due to gravity as it is the acceleration produced in a freely falling body due to the force of gravity. Acceleration due to gravity is represented by small g. It is vector quantity. Its SI unit is meter per second square. When a body is thrown vertically upwards, g is taken as negative because here body is moving against the gravity. When a body falls towards the earth, g is taken as positive. Let us see how to get acceleration due to gravity at the surface of the earth. Consider that earth and the object separated by distance d. The mass of the earth is capital M, whereas the mass of the object is small m. Now, according to Newton's universal law of gravitation, the force of attraction between these two, that is between the earth and the object, is given by capital G into capital M into small m upon d square. Yes, call this as equation 1. When this body or this object falls freely under the effect of gravity, a constant acceleration is produced in it, which is the acceleration due to gravity, that is small g. Now here, using Newton's second law of motion, the force applied by the earth on the object of mass m is given by, we know that force is equal to mass into acceleration, but here acceleration is acceleration due to gravity. That's why we are using here symbol g, which represent it is acceleration due to gravity. Now equating these two, we will get m into g is equal to capital M into this m into m upon d square. Now here this m is the mass of the object, whereas this m is also the mass of the object, which will be same. So cancel this from both sides. We will get that small g, that is acceleration due to gravity, is equal to this capital G into m upon d square. Now here consider that object is very close to the earth. It is very near to the earth. Then the distance between them will be considered as the radius of the earth. Hence, this equation will be reduced to g is equal to capital G into m upon r square, where that m is the mass of the earth and r is the radius of the earth. Now here we got g is equal to capital G into capital M upon r square. We know the values of all. That value of g is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Then mass of the earth is 6 into 10 to the power 24 kg, and radius of earth is 6.4 into 10 to the power 6 meter. Now substituting all these values in this equation, you will get, and calculating, you will get the value of g as 9.8 meter per second square. We have derived that small g is equal to capital G into mass of the earth upon square of the radius. It means that the acceleration experienced by an object is independent of its mass, because there is no term like m or mass of the object in that formula. That means all the objects, hollow or solid, big or small, should fall at the same rate. All bodies fall freely under the effect of gravitational force of the earth with constant acceleration. Hence, their motion is uniformly accelerated motion. All the three equations of motion which we have derived in chapter motion can be applied to the motion of freely falling bodies. The acceleration A is replaced by small g, S is replaced by the height h, and all the three equations of motion are modified for the motion under gravity as V is equal to u plus gt, h is equal to ut plus half gt square, and v square is equal to u square plus 2gh, where u and v are initial and final velocities, h is height of the object, and g is acceleration due to gravity. Let us discuss the difference between mass and weight. Now, mass is the amount of matter contained in a body, whereas weight is the force exerted by the earth on a body. Mass is a scalar quantity, whereas weight is a vector quantity. The unit of mass is kg, whereas the unit of weight is Newton. The mass is constant everywhere in the universe, whereas the weight is not constant everywhere and it changes with the change in acceleration due to gravity, because we have seen W is equal to m into g, mass into acceleration due to gravity. As the acceleration due to gravity will change from place to place, weight will also change. Mass is measured by beam balance, whereas weight is measured by a spring balance. We know that the weight on moon is nearly 1/6 of the weight on the earth. How we got this? Let us see. We know that weight is nothing but the force with which an object is attracted towards the earth. So here the weight of object of mass m on earth is nothing but the force with which it is attracted towards the earth. It will be given by capital G into mass of the earth into that mass of the object upon square of the radius of the earth. In the same way, the weight of the same object on moon will be given by the force with which it is attracted towards the moon, that is capital G into mass of moon into the mass of the object upon square of radius of moon. Yes. Now we know that the mass of earth is nearly 100 times the mass of moon and the radius of earth is nearly 4 times the radius of moon. Now using this we will try to solve. Now here we will take the ratio of weight of moon to the weight of earth. So weight of moon is capital G into mass of moon into the mass of the object upon square of that radius of moon. Now here upon WE, that is weight on earth. So we will take the reciprocal of this, multiply by that square of the radius of earth upon capital G into mass of earth into mass of object. Now mass of object will be same everywhere and we are considering the mass of the same object. So that m will get cancelled, then G is same. So it will get cancelled. Now here mass of moon into, now radius of earth is 4 times radius of moon. So here we will write 4 Rm whole square upon here as it is Rm square into, now mass of earth, so here it is 100 into that mass of moon. Yes. So here you will get into 4 square is 16 Rm square upon this Rm square into 100 into that mass of moon. So this will get cancelled, this will get cancelled, and what you will get is weight of moon upon weight on earth is equal to 16 upon 100, which is nearly equal to 1/6. Yes. So you can say that weight on moon is nearly equal to 1/6 weight on earth.